Let's now look at some exam questions regarding independent and dependent variables and conditional probability. The first question is this one from a June 2005 exam. Question 5, it says, data about employment for males and females in a small rural area are shown in a table. And you are given this table over here with information about male and female people in this rural area and the number of employed and unemployed. A person from this area is chosen at random. Let M be the event that the person is male, and let E be the event that the person is unemployed, or employed, sorry. First question is find P of M. So the probability that it is M. M is the event that the person is a male. So what is the probability that the person is a male? Well, the probability that the person is a male is these two values put together. Doesn't matter if they are employed or unemployed. What matters is that they are a male out of the total number of people. I already compiled that information and added important bits over here. So this is what you have. And this is the total number of male. This is the total number of female. This is the total number of employed people. And this is the total number of unemployed. And this is the total number of people. Adding these two together or adding these two together, you should reach the same value, right? So the probability that a person is male is the number of males out of the total number of people, right? Then find the probability or find a probability of P and E. So probability of, not P, the probability of M and E. So the probability that you have a male employed person, that's this number over here, 412, out of the total number of people. And then the question is, are M and E independent events? Justify your answer. Again, if you have to show or test the dependency or independency of events, this is what you have to do, okay? If they are independent, this should be this value over here and this value over here should be the same. So the probability of being a male and employed should be given by the probability of being a male times the probability of being employed. So all you have to do is to calculate these and figure out if they are the same or not. This value you already know. This value you already know. You have to calculate this one. So the probability of being employed, that's 717 out of the total number of people. And now let's just calculate each side. This one you already know from the question 2. Multiplying these two, you have this value, and these two are different, so they are dependent. Okay? Last question is given that the person chosen is unemployed, find the probability that the person is a female. All right? They represented M as the event in which the person is a male, so I'm not going to put an F here. I just put M dash to represent female. So you want a probability that the person is a female, knowing that it is unemployed. All right, so the formula is this: the probability of female and unemployed out of what? Out of the probability that it is unemployed. This is what? This is 305. No, sorry, 358. So unemployed and female, 358 out of the number of unemployed, which is 564. That is it. Okay, so here is the result. Next exam is from June 2006, and it's this question over here. The probability that Hank goes swimming on any day is 0.2. On a day when he goes swimming, the probability that Hank has burgers for supper is 0.75. On a day when he does not go swimming, The probability that he has burgers for supper is X. This information is shown on the following tree diagram. You also know that the probability that Hank has burgers for supper on any day is 0.5. First question, find X. Okay. In green, it's what you already had in the question. So you have to finish at least part of this tree to get the answer. You know that the probability that he has burgers, regardless of going swimming or not, is 0.5. Okay? So the probability of B is what? Is given by what? Is given by these two paths. The probability that he has burgers is this probability over here. He goes swimming and then has burgers. All right? And you also have this path over here. It does not go swimming and has burgers. So that's going to be 0.2 times 0.75 plus 0.8 times x. And you know that this should be equal to 0.5. So you have here a very simple linear equation. You get the value of x very easily. And by the way, you can also get this value over here, which is 1 minus x. Then the second question is, given that Hank has burgers for supper, find the probability that he went swimming that day. So the probability that he went swimming knowing that he ate a burger. So that's the probability of S and B out of the probability of B. So what is the probability of S and B? That's this one over here. S, well, we already calculated that before. It's 0.15. Where did I get that? Yeah, is this one over here, 0.15. Out of what? Out of 0.5. The probability that he got burgers, which is given by the question. All right, so very simple question overall, this one. Next one is from November 2005, and it's question 2. Boxes of sweets contain toffees and chocolates. Box A contains 6 toffees and 4 chocolates. Box B contains 5 toffees and 3 chocolates. And box C contains 3 toffees and 7 chocolates. One of the boxes is chosen at random, and 2 sweets are taken out, one after the other, and eaten. Find the probability that they are both toffees, and then, given that they are both toffees, find the probability that they both came from box A. So, what you have here, you have basically 3 events. The first event is the picking of the box. You have 3 options, A, B, and C. And then you have 2 events, the event of taking 1 sweet, and then the event of taking the second sweet. I use this making a tree diagram with these 3 events. So here is the first event, picking up the box. You have equal chances of picking up the box, that's 1/3, right? Then taking the first sweet. On the first box, you have a total of 10 sweets, and you are told that 6 of them are toffees and 4 chocolates. So that means that you have a 6 out of 10 chance to get a toffee and 4 out of 10 of getting what is the other flavor? Chocolate. And same thing after. All right, regardless of what happened in the second event, the first sweet, then the conditions are going to be slightly different, the probability, because you already have taken 1 of them. So if you've taken 1 toffee, now you are left with 5 out of 9 sweets, okay? And you still have 4 chocolate out of 9 sweets. If you've taken 1 chocolate, then you still have 6 toffees out of 9 sweets, but 3 chocolates out of 9, right? For the other, I just did a similar approach, just check the numbers, but you are going to have the corresponding probabilities on top of each line. All right? Now that I have the tree diagram done, I can actually calculate what is being asked. And the first question again was, find the probability that they are both toffees. So how many different paths you have? You have the path of getting box A and then toffee toffee, the box B and toffee toffee, and box C and toffee toffee. All right. So this is going to be 1/3 times 6/10 times 5/9 plus 1/3 times 5/8 5/4 plus 1/3 times 3/10 times 2/9. All right. Plug everything in the calculator. That's the result. Actually, the main difficulty on this question is to build the tree. Once you have the tree, you can get everything that you want. This is true for any other question for which you don't have a tree, like you did on this one. All right. Then, given that they are both toffees, find the probability that they both came from box A. So now you know that they are both toffees, and you have to calculate the probability that they came from box A. So this is the formula that you know already for a long time. The probability of A and I called it TT, being both toffees, out of the probability that they are both toffees. So what is this? This is this path over here. A, toffee, toffee. Here are the probabilities. Out of what? Out of the probability that they are both toffees, which you just calculated before. Okay, and this is the final result.